Today we'll see another important topic in operating system, which is a PCB and their thread models. Let's see one by one. PCB. What is a PCB? PCB is like a IDT card or a file that OS keeps for every single process to maintain that program. So what it actually stores in, we'll see an important fields in a structure diagram. It actually stores the process state and the number and also the counter for the particular program with the register and the memory limits. So basically what it stores is like inside the PCB, the OS stores some important things, right? So it actually the process ID and the current state, it is running, ready or waiting or finished, and the program counter, which is which line of code will run the next, and the all the CPU register values saved when we have to switch to another process, like the memory limits and also the list of open files with the priority levels and also the system CPU that has been used there. This info helps the OS to do the context switching and also manage the process properly. Now coming to the threads. We have threads are like small tasks inside the one process, as we have seen this before. We have two types, which is a user level and the kernel level. Let's go on to the user level. These are managed by the application or a library, not by the OS. Very fast to create and switch between them. But the OS is only one process. It doesn't know about the threads separately. So if the one thread waits, for example, for the file is reading, the whole process waits. Also, they cannot truly run on the parallel on the multiple CPU cores. Let's move on to the next one, which is the kernel level threads. These are managed directly by the OS kernel. The OS knows every thread separately and they can schedule them independently. So they can run truly parallel on the multi-core processor, better for performance and the scheduling. But creating and system switching to them is slower because the kernel has to be get involved. So in short, we have this comparison between the slow mapping and the structure between the single threaded and processor and multi-thread processor by parallelly running. Mostly, this is the most common difference over there. And when coming to the quick summary, the user level threads, the fast and lightweight but limited power. Kernel level threads more powerful and really parallel but a bit heavier. That's it. The PCP is the brain file of the process and threads it lets helper.